Okay, in this video, I'm going to kind of go over how to balance nuclear equations, so maybe this will help. So what I have here is uranium-92, uranium-238 has an atomic number of 92, and it's going through some type of decay because it's breaking apart. It's not an alpha, it's not a beta, it's just happening. And so how you would balance this is you have to take all the numbers on top, which I'm going to highlight in blue, and then we're going to solve this like a math class. So we're going to take that 238. Instead of an arrow, we're going to put equal. Now this one's a little tricky because there's a 1 on top, but there's 2 of them. So that's really 2 times 1. So it's really 2 plus 85 plus some number x. And then we just solve for x. So this is 238 equals 87 plus x. So then I just need to take 237 and subtract 238 and subtract 87. Pulling up my handy dandy calculator because I don't want to put the wrong answer. And you get that x is equal to 151. That means right here we put 151. Okay, so now we're going to do the bottom numbers. 92, there's a 0, a 36, and some unknown. So now we're going to look at the yellows. So this right here was for the blues. Okay, so 92. We're going to treat the arrow like an equal sign. 2 times 0, still 0, plus 36 plus some number, we're going to call it x. So you solve this the same way. 92 equals 0 plus 36 is just 36 plus x. So then we're going to figure out that x is equal to 56. And then you take this number right here and you look at the periodic table and you identify that this element is barium, Ba. So that's how you balance a nuclear equation. Now, how to write a nuclear equation. Let's say, actually, let's do one more balance. Let's say that you had something like and I am making this up. Okay, so let's look at this one. Okay, again, I'm going to highlight the top parts in blue. So 80 plus 1, treat this like an equal sign. This is my unknown x plus 36. So 81 minus 36 is 45. So that means my top number is 45. Okay, now let me do the bottom numbers in yellow. 35, 0, some number, and 17. Oops. Now subtract 17 from both sides, and we get that x is 18. And that is argon. So that's how you balance nuclear equations. And then in this video, I'm going to go over how to do alpha and beta decay. So the word decay implies that it's breaking apart. So the most common ones that you kind of see this might be 234 thorium. And so it'll say alpha decay of thorium 234. So you have to remember that that 234 is the number that goes over here on top. Okay, if it goes through an alpha decay, there's a pattern that you have to follow. You write down your isotope that it gives you, you write your arrow, and then you write in your alpha. Now your alpha can be this symbol or it can be He plus something. And then you're going to balance it just like you've done on the last two. 234 equals 4 plus some number. So that's going to be 230. Then your bottom numbers, 90 equals 2 plus some number. This will be 88. And then you can check yourself. 230 plus 4 is 234. 88 plus 2 is 90. 88 is the atomic number for radon. For beta decay, let's say that potassium 40, I said 40, but I wrote something else. So potassium 38 is going to go through beta decay. So you take potassium, it's K. This 38 goes on top. Potassium has an atomic number of 19 from the periodic table. It's going through a decay, which means we write an arrow, and then we write a beta plus something. Again, top numbers. 38 equals 0 plus some number. Well, that one's fairly easy. It's going to be 38. Our bottom numbers, 19 equals -1 plus something. And this is where it gets a little tricky because it's a -1. So this one actually has to be a 20. So you just kind of double check yourself. 20 plus a -1 is the same thing as 20 minus 1, which gives you 19. And the atomic number, or the element for atomic number 20, is calcium. So that's your alpha and your beta.